Hey everyone, and welcome back to our section on Seaborn. In this one, we're going to explore some of the different categorical plot types that we have available. There are numerous different types of categorical plot that we could use, but in this lecture, we're going to focus on the main three, which are bar charts, count plots, and box plots. The other options, such as violin plots and swan plots, are helpful in certain cases. However, they do tend to be a little more impractical for the vast majority of situations, as they're much more niche, and quite often you'll find that people don't understand how to interpret them. So we'll just focus on the most helpful and beneficial of these charts. Let's move on over into our Jupyter notebook and get started. Okay, so here we are inside of Jupyter Notebook. For this lecture, we'll just be using the same MPG and tips datasets as we used before. So I'll go ahead and import these and then assign them to a variable. The first type of categorical plot that we'll look at is the bar chart, which in Seaborn is known as a bar plot. And these should be pretty familiar, as we've looked at these in both Excel and Matplotlib, so hopefully these will be pretty familiar. To create a bar chart, we'll go ahead and call the sns.barplot function, and then we'll need to provide it with a few key arguments, which will be our x-axis, y-axis, and the data. I'll set our x-axis as one of the categorical columns in our data frame. And just to recap, a categorical column is just a column that contains different categories for our data. So in our MPG data frame, a good example of a categorical column would be the origin, as this column contains three different levels, which are the USA, Japan, and Europe. So let's say that we'd like to see how the MPG varies for cars by their origin country. I'll set X to be equal to origin, and then for our Y value, this is where we get to specify what numbers or values we want to plot. In this case, we wanted to see the MPG, but we could also show the horsepower or weight, for instance, too. And then finally, the data will just be the name of our data frame. So I'll set this to be our MPG data frame. And then running this cell will create a bar plot, which by default shows the mean or average of the y-axis. So in this case, that'll be the mean of our MPG for each country of origin. We can see that the USA has the lowest average miles per gallon, followed by Europe, and then Japan has the highest average miles per gallon. As another example, let's use our tips data frame and have a look at how the total bill varies by the time of day. I'll call our bar plot function again, but this time for our x-axis, I'll set it to be our time column, and then our y-axis values will be the total bill, and then the data will just be our tips data frame. And looking at this, we can see that meals ordered for dinner tended to have a larger bill, and also, just to show you here, we can also specify the hue argument on our bar plots too. So if I say that hue is equal to our smoker column, this will break our results down even further by the data for our smokers and non-smokers, which allows us to see that people who smoke tend to have the largest bills. And this is true for both dinner time as well as lunchtime too, albeit by a much smaller margin at lunch. Another argument that I'd like to quickly show you for our box plots is the estimator, and this is just what sets the aggregate function that will be used for your plot. And this is the description from the documentation in Jupyter. If we go ahead and import NumPy, we could pass in np.median for the estimator, and then this will plot the median for our values instead of the mean. Any of the other aggregate functions that we've looked at, such as min, max, or standard deviation, for example, will work here too. Okay, and moving on, we then have our count plots, which are very similar to bar plots, but instead of calculating the average, they actually count the number of occurrences instead. So we don't need to specify our y value. Going back to our example before with MPG and country of origin, I'll just say here that X is equal to the origin column, and then the data will be the MPG data frame again. And then this is basically just showing us the count or number of occurrences for each origin instead. So USA had the most cars in that data set, followed by Japan, and then Europe close to behind. The final type of plot that we'll look at in this lecture are box plots. We've looked at box plots already in the course, so these again should be fairly familiar, but just to recap, a box plot is basically just a graph that shows the distribution of a set of data, including its quartiles, minimum and maximum values, as well as its median and any outliers. I'm going to create a box plot on our MPG column, which we'll use again to look at how our miles per gallon varies by the origin country. I'll call sns.boxplot, and then this function will need the same three arguments as our bar plot, which were x, y, and the data. Our x-axis will need to be a categorical variable or column, which I'll use as the origin column, and then y will need to be a numeric column. We wanted to look at the miles per gallon, so I will set y to be equal to the MPG column, and then our data will just be the MPG data frame. And this will create a box plot, which is very similar to the box plot that we had in Matplotlib and Excel. The box extends to show our quartiles, with a line in the middle that shows the median value. The whiskers then extend to show us the range of our data, but the important thing to note here is that the whiskers exclude any outliers. Whiskers usually span to 1.5 times the interquartile range, so they help us to see how the data is spread out beyond the quartiles. And then finally, beyond our whiskers, we've got a few small dots, and these represent any outliers in our data. And this again clearly shows us that cars from the US have the lowest typical miles per gallon compared to Japan and Europe. But all of our different countries have a few outliers with a high miles per gallon for that country. Before we finish, let's have a look at another quick example, but this time we'll use our tips data frame. I'll call sns.boxplot, but this time I'll use the day column for our x-axis, and then for our y-axis, I'll set it to be the total bill. And then just finishing off with our data at the end here too. Before I run this, I'm actually going to pass in the hue argument, which I'll set to the smoker column. And this will work in the same way as it did before, by breaking our results down by the categories in that column. And now looking at this, we get our results, but broken down for both smokers and non-smokers. And this figure plot is a little small, so I'll go ahead and make this figure a little larger by specifying our figure size, which I'll set to 16 and 6. Okay, perfect. So we can clearly see here how our total bill varied by the day, but then broken down even further for smokers and non-smokers, thanks to the hue argument that we specified. And make sure to remember the hue argument, as it's a very helpful one, and you'll probably end up using it quite a lot during your data analysis work. Okay, and that there wraps up our lecture on categorical plots within Seaborn. I hope you're enjoying this section so far, and Seaborn is making sense. In the next lecture, we'll have a look at the matrix plot types, which are a very helpful way to visualize the correlation between different variables. Thanks everyone, and I'll see you all in the next lecture.